Okay, so today we're going to continue our exploration of simplifying expressions with rational exponents. And our key for success today is recognizing that a raised to the rational exponent, so m over n, is equivalent to the radical expression of the nth root of a to the m power. So the reason that's going to be important today is because we're going to talk about some problems that deal with this issue when we pose it in a fraction. So let's get to it. All right, so getting to it. All right, so first things first, what we have here is just the problems with just different types of rational expressions. And we've done some of these, but we haven't really focused on what happens if I'm left with a rational exponent in the denominator of a fraction. So taking a look at this one, this is an issue. And here's why it's an issue. Because remember, a rational exponent, which you just went over, is literally the same thing as a radical expression. And you've learned for a couple of years now, hopefully by the time you got to Algebra 2, that you're not allowed to leave a radical in the denominator. So let's talk about how it is that we can simplify this, because this is not simplified. And the reason it's not simplified is because there is a rational exponent in a denominator. So another little tidbit that you need to remember now is you're not allowed to leave rational exponents in denominators. So here we go. Let's go ahead and do this. So how on earth do we do this? So much like you had radicals, okay? When you had a radical, what you did, most of the time you focused on square roots. And to get rid of a square root, you just had to multiply the root by itself. Well, that's not going to be the case when you deal with rational exponents or other nth roots. When you deal with other rational exponents or other nth roots, okay, what you need to do is you need to essentially complete the root. And how do you complete a root? Well, you turn a rational exponent into a whole number. So if I want to turn 4/5 into a whole number, what do I need to add to 4/5? So taking a look at example 1, it has 1 divided by w to the 4/5 power. So what do I need to add to 4/5 to make it a whole number? Because then it's no longer a radical once you take it out of a rational exponent. And what you need to add to 4/5 is the value of 1/5. 4/5 plus 1/5 is equivalent to 5 over 5, which turns into 1. So, with that being said, you have to also keep in mind that you're dealing with the fraction being in an exponent. And the only way you get to add exponents is when you multiply bases, okay, that are alike. So, in other words, what I'm going to need to do here is I'm going to need to multiply this by another w. But I don't want to just multiply it by w. I want to multiply it by w to the exponent that completes 4/5 into a whole number. So, let's go ahead and do that. So now we've already discussed that, and we said it was 1/5. So we now know that 4/5 plus 1/5 equals 1. But just don't forget that when you multiply an expression, you must multiply both numerator and denominator by the same value. So what I end up getting left with here is I get w to the 1/5 power, because 1 times w is w to the 1/5, divided by w to the first power. And then this is now the proper way of leaving it. Okay, we can leave it just like that. Now, if you wanted to convert it, you could absolutely convert it into the 5th root of w divided by w. And now you'll see it as you more commonly do, okay, when it's written in radical form. So, I hope you understand that, but we're going to go through another problem that's kind of just like this. All right, just using different numbers. So, example B. Example B has b to the 4/7. So I'm going to focus on the 4/7 right now. I'm going to say to myself, well, how do I turn 4/7 into a whole number? Well, turning 4/7 into a whole number means it needs 3/7 more. So 4/7 plus 3/7 is equivalent to, again, in this case, 1. So here we go. So, but to add 3/7, the 3/7 has to be in an exponent. To add exponents, you have to multiply by like bases. So what I'm going to do is I'm going to multiply this by the base of b to the 3/7. So essentially what I'm doing is I'm completing the rational into a whole. And I multiply the top by b to the 3/7. And what I get left with is b to the 3/7 divided by b to the first power, because 4/7 plus 3/7 is 1. Now, this can also be rewritten as, because I want you to see it both, just in case you have or you're on a test or whatever it may be in the future, that this could also be commonly written in its radical form. So I could write this as the 7th root of b to the 3rd power divided by b. So I hope that makes sense, but for now it doesn't matter which one you take. It doesn't matter for me if you leave it as the rational or if you want to convert it into the radical form. It's all good. Okay, so let's take a look at C. So C says t to the negative 3/2. Well, we don't leave things with negative exponents. So converting this very quickly, it becomes the reciprocal, and the reciprocal is 1 divided by t to the 3/2. Well, the problem is once we take the reciprocal, we get left with a rational expression in the denominator. So the question is how do I turn 3/2 into a whole number? Well, 3/2, if I give it another 1/2, makes 4 over 2, and 4 over 2 turns into 2. So what I'm going to do here is I'm going to, again, remembering, okay, before we move forward, that to add a value to an exponent, you have to multiply it by a like base with that exponent. So I must multiply it by t to the 1/2, multiply the top by t to the 1/2, and what I get left with is t to the 1/2, and 3/2 plus 1/2 is 4 over 2, which is t squared. So my final answer to this one in radical form, if I wanted to write it like that, would be the square root of t divided by t squared. So again, I don't care which one you personally leave me with for this video, for the problems I give you, but it's just some examples. All right. So moving forward, we're just going to keep doing this, and you'll see a common theme today where you're going to be left with a rational exponent in a denominator. So the goal is to be completing these denominators with other rational exponents. So let's take a look at D. So D says w to the negative 3/8 times 4/9. So when I multiply, when I take an exponent raised to another exponent, I multiply them. So I'm going to do w to the negative 3/8 times 4/9, and I get w to the negative. Now, if you're old school like me and you're doing this by hand, we do what we call front-end reduction. So I look for factors in the numerators that reduce with factors in the denominators, and I see 3 reduces with 9, and 3 becomes 1, and 9 is 3. The 8 reduces with the 4, and that becomes a 1, and that becomes a 2. Now, why is that important? Because now it makes my math a little bit easier. What's 1 times 1? And it's 1. And what's 2 times 3? It's 6. Now, again, that presents a problem because we won't leave a negative exponent. So this turns into w. Sorry, not w. This turns into 1 divided by w to the 1/6. And now I have to ask myself, well, how do I turn 1/6 into a whole number? Well, if I give 1/6 5/6 more, then what I'm left with is a whole number. So what I'm going to do is I'm going to add 5/6 to 1/6, but I must do it by multiplying first by a like base, and that like base will be raised to the 5/6. So I multiply top and bottom by 5/6. And what I'm left with for a final answer is w to the 5/6 all over w. Now, if you want to write this in radical form, it would look like the 6th root of w to the 5th divided by w. And there's my final answer. All right, so on to E. So E, the same thing. We'll go through this problem. So negative 2 times 3/4 ends up being x to the negative 3/2. And then I do the next one, which is y. So 1/3 times 3/4 is 3/12, which is also known as 1/4. So let me erase that really quick. So there's that. And we make this into a 1/4. All right, so now we have an issue. And the issue is that has a negative exponent. So we convert it really quickly into y to the 1/4 divided by x to the 3/2. And then we look at this and we say, okay, this rational exponent means that it's a radical expression, so we can't leave those in denominators. So what I'm going to do here is I'm going to multiply top and bottom, okay, by x, and I'm going to multiply it by 1/2, because 3/2 plus 1/2 makes a whole number, and multiply this by x to the 1/2, and this will be equal to y to the 1/4, x to the 1/2, divided by x squared. Now, the numerator is kind of tricky, right? Because if I want to write this in radical form, what I need to have now is I need to have all of the denominators there as the same thing. So to add up to the level of this one, to make it a more complicated, a more challenging problem, we've already done problems where we took rational expressions in the exponent and we wrote them as a single radical. So I'm going to do that here. So the problem is that the y has a denominator of 4 as an exponent and the x has a denominator of 2. So just to add a little complexness to this, what I'm going to turn this into, let me move over here a little bit, focusing on it. Okay, what I'm going to do is I'm going to convert this into y to the 1/4, and this becomes x to the, 1/2, and fourths is written as 2/4 divided by x squared. So now that allows me to write this final answer, if I wanted to in one radical form, would be the 4th root of y to the 1st x squared divided by x squared. And then this one would be done in radical form. Okay, so do not, if you're going to leave it in rational, it's okay, but if you're going to leave it in radical form, you have to convert it to like this. Now, the one in radical form is more something you see on your SATs. So I would practice them while you're doing it here, while you're learning it. But again, it's extra for practice that I'm going to give you. I'm quite okay with you leaving it like this for now, but we will in the future get to something like leaving it in radical form. All right, so now let's go back to our last example, which was somewhere around here. Or did I already do it? Yoop. Oh, there it is. Tucked hidden away. Woo! All right, so let's get rid of that stuff now that we've seen it. Doop. Doop. All right, so we'll move that out of the way. Boop. Okay, so moving this out of the way. And then we'll bring this one over here, and we'll focus down in on it. All right, so here's my problem that I want to do. So my last problem of the day, okay, is this one. So we're going to go ahead and do it. So 5 is now in there. It's a number that's in there. So don't forget 5 is a value. So what we're going to do is we're going to do this problem. It becomes 5 to the 1/5 power. Okay, x to the, 1/3 times 1/5 is 1/15. And y to the -2 times 1/5 is y to the -2/5. Okay, so now we have a couple issues here. And the issue is going to be that this is a negative exponent. So first things first, let's change it to the positive by taking its reciprocal. So I get 5 to the 1/5 x to the 1/15 divided by y to the 2/5. Now again, this bottom thing presents an issue when I do that, because when I take the reciprocal of that negative exponent, it puts a rational expression in the denominator. So now I need to be thinking about how do I turn 2/5 into a whole number, and I need to add 3/5 to it. So when I go ahead and add 3/5, I just need to remember if I want to add to an exponent, I got to multiply by a like base. So I'm going to multiply by a like base of 3/5, and I'll multiply the top by y to the 3/5. And what I get left with is, in the numerator, 5 to the 1/5, x to the 1/15, y to the 3/5, divided by just y. And now for me, I'm happy with that. You could leave that as an answer, but if you wanted to get more on the level of the SATs, okay, so your SATs, you're going to want to be able to convert that all into one radical. So to do that, I just have to look at the denominators. I need common denominators in my exponents, and the common denominator would be a 15. So 1/5 would turn into 5 to the 3/15. And this is going to stay x to the 1/15. And then y would turn into, if I want to turn to 15, turn it top and bottom by multiplying by 3, and I get 9/15. divide that whole expression by y, and I will get it's the 15th root of 5 to the third power. Now 5 to the third power, instead of writing it, I'm just going to give the value. 5 to the third power is 125. X to the first power, y to the ninth, divided by y. And now you have more of like an answer that would appear on your good old SATs. All right, so I hope that was helpful, that you got all those examples, you wrote them down. Rewind back if you need to. Sorry this video is a little bit longer, but there was a bunch of different examples I had to give you. But after this, let's talk about the practice problems. So there's 8 practice problems I'm going to give you to kind of just cycle through what I did to try it on your own and see how it works out for you. So give them a go, and if you're one of my students, what I'm going to do is turn them in when you're done with them so I can go ahead and check them. All right, have a good night.